In 1978, a rat was placed alone in a small metal cage. Inside were two water bottles. One held plain water. The other was laced with morphine. Within days, the rat was hooked, drinking itself into oblivion, exactly the way every textbook said it would. This was the standard addiction experiment of the era, run in labs across the world for decades, always the same basic setup. Isolated cage, two bottles, same result almost every time. The conclusion seemed obvious. The drug was the problem. The chemical reached into the rat's brain, rewired it, and there was nothing the animal could do about it. Humans, the thinking went, worked the same way. Try the drug enough times, and the drug takes over. Free will simply switches off. This idea became the foundation of decades of policy, the backbone of just say no campaigns, and the justification for treating addiction as a permanent, almost mechanical hijacking of the brain. A psychologist named Bruce Alexander wasn't convinced. He noticed something strange about every one of those experiments, something so basic that almost nobody had thought to question it. The rats were always alone. Small cage. Nothing to do. No other rats. No toys, no space, no choice in anything. An animal that is naturally social, curious, and active was being tested for its relationship with a drug inside conditions that would be closer to solitary confinement than to anything resembling a normal rat's life. Alexander wondered whether the addiction wasn't really about the morphine at all. Maybe it was about the cage. So, in the late 1970s, at Simon Fraser University in Canada, he built something different. He called it Rat Park. It was 200 times larger than a standard lab cage, painted with murals of forests and hills, littered with cedar shavings, tin cans to play in, wheels to run on, and platforms to climb. Most importantly, it wasn't a solitary box. It housed a colony, males and females living together, free to socialize, mate, and roam. Then Alexander gave the Rat Park residents the exact same choice as the isolated rats. Plain water in one bottle, morphine-laced water in the other. Same drug, same concentration, same access. The only variable being the world the rat got to return to after drinking. The results didn't just differ, they collapsed the entire theory. The isolated rats, alone in their small cages, drank the morphine water compulsively, some of them almost exclusively until it killed them. The Rat Park rats, with company, space, and things to do, mostly ignored it. Even when Alexander made the morphine water sweeter to make it more tempting, deliberately trying to force the addiction to take hold, the Rat Park rats still drank far less than their isolated counterparts. Some tried it once or twice, sniffed around the bottle out of curiosity, then went back to plain water and their colony. A few had been made dependent on morphine beforehand, forced into it through weeks of isolated exposure before being moved into Rat Park, and even they, once given a full life to return to, cut back sharply and endured mild withdrawal rather than keep choosing the drug over their new environment. Same rats, same drug, same dose available. A completely different outcome depending only on what kind of world the rat was living in. Alexander published his findings in 1978 in the journal Psychopharmacology, and the implication was massive. Addiction wasn't simply a chemical hijacking a brain. It was, at least in large part, a response to isolation. A rat with nothing else to do and no one to do it with would take the drug, because the drug was the only source of relief available. A rat with a full life mostly wouldn't bother because it already had things worth paying attention to. The bottle wasn't winning because it was powerful. It was winning by default because it was the only thing on offer. But here's where it gets stranger. Rat Park should have reshaped addiction science overnight. It didn't. The study struggled for years to get published in top journals. Some scientists dismissed the sample sizes as too small. Others pointed out inconsistencies across different runs of the experiment, noting that not every replication produced results as dramatic as the original. And there's a less scientific reason it stalled too. The chemical hijacking theory was simple, tidy, and useful. It fit neatly into a war on drugs framework that treated addiction as an individual moral failure to be punished, not a symptom of an environment to be fixed. It was easier to fund a prison than to fund a park. Rat Park complicated that story, and for a long time, complicated stories lose to simple ones, no matter how much data backs them up. Decades later, researchers went back and looked at what actually happens to humans in extreme isolation. And the pattern showed up again in a place nobody expected: the Vietnam War. Nearly 20% of American soldiers serving in Vietnam used heroin regularly enough to be considered addicted, under conditions of extreme stress and total environmental control, far from home, with no autonomy over their own lives, surrounded by death and boredom in roughly equal measure. Doctors and policymakers back home braced for a mental health catastrophe when those soldiers returned, expecting hundreds of thousands of newly addicted veterans to overwhelm the healthcare system. It never happened. Follow-up studies led by psychiatrist Lee Robbins found that around 95% of soldiers who had been addicted in Vietnam simply stopped without treatment, without relapse, once they returned to their old lives, their families, their routines, their sense of purpose. The chemical hadn't rewired them permanently the way the old theory predicted it must. The environment that produced the addiction had ended, and so mostly did the addiction along with it. Which brings us back to the cage, and to something closer to home. Look at how most people actually live now. Long stretches of isolation disguised as connection, hundreds of online friends, and almost no one to call at 2 in the morning. Physical spaces that keep people apart even in dense cities, an apartment building where nobody knows their neighbor's name, jobs that offer little sense of purpose or community, hours traded for a paycheck with no colony to return to at the end of it. And then, in every pocket of downtime, a single glowing bottle available at all times? The phone. Endless, frictionless, always ready to deliver a small hit of relief the moment boredom or loneliness shows up. No waiting required. Researchers studying social media and dopamine have found strikingly similar patterns to Alexander's rats. People with strong in-person social ties, engaging work, and a clear sense of purpose tend to use their phones compulsively far less than people who lack those things, even when the app itself is identical for everyone involved. The addictive pull isn't uniform, and it isn't just about how well an app is engineered. It concentrates precisely in the empty spaces where connection and meaning are missing, the same way morphine concentrated in the empty spaces of an isolated cage. There's a version of this playing out in ordinary lives, not just labs. In 2019, a man named Newport interviewed a woman for his research on digital habits who described deleting every social app from her phone after a divorce left her checking it compulsively, sometimes 200 times a day, mostly late at night, mostly alone. She assumed she'd simply relapse within a week, the way people assume an addict always relapses. She didn't. What actually broke the habit wasn't willpower or an app blocker. It was joining a weekly pottery class and reconnecting with 2 friends she'd let drift for years. The phone checking didn't get willed away. It got replaced. The same way Alexander's rats replaced the morphine bottle with cedar shavings and company, the moment something else became available to reach for instead. None of this means willpower or brain chemistry don't matter. They do. Some substances and some platforms are engineered specifically to be harder to put down than others, built by teams whose entire job is maximizing the time you spend reaching for the bottle. And that engineering is real and worth taking seriously on its own terms. But Alexander's rats suggest the full picture was always bigger than the drug itself, or the app itself. Addiction, in rats and in us, seems to grow best in an empty cage, no matter how comfortable or brightly painted that cage is made to look. The isolated rat never had a choice about its world. It got a small metal box and 2 bottles, and it did the only thing available to feel something. We build our own cages too, usually without noticing we're doing it, one convenient habit at a time. And unlike the rat, we get to choose, at least sometimes, whether to fill that cage with people, purpose, and something to do, or leave it empty and reach for the bottle that's always sitting there, within arm's reach,